Alright, so in the final part of this documentary, we will talk about the evolution of facial recognition in insects. And the first thing we will do is we will look specifically at the Polyestes wasp. Alright, so the first thing I want to note is that there are three types of Polyestes wasps. Well, three main types of Polyestes wasps. And they're all eusocial, as we defined before by the three requirements, which is brood parental care, and the overlapping generations, and the reproductive caste. And even though all these types of Polyestes wasps are eusocial, they produce three different types of nests. The first type of nest is a single founder's nest, where only one queen finds the nest. The second type of nest is an obligate founder's nest. And this is between when multiple queens find the nest and they fight it out, and there's only one dominant queen that lays eggs and gets all the food, and a whole bunch of sub-queens that don't lay eggs and don't get food. A third type is flexible, multiple single founder's nest. Oh, this should be multiple. Similar to the obligate multiple founder's nest, a whole bunch of queens, or maybe one queen, will find the nest, but then all the queens fight it out, and this gives linear dominance. Where unlike this one where one queen gets all the power and the other ones are like nothing, in linear dominance, you have like a distribution of power. Maybe like one queen will get like a certain amount of food and a certain amount of nests, and then the more powerful queen will get more food and a bigger reproduction row, and then you have this top queen who gets like the most food in the reproduction row. And then we're gonna talk about like repeated evolution of facial pattern variation. And we're gonna talk about a very, very, very key experiment. So there are these two guys, and they wanted to figure out how efficient insects were at developing facial recognition and other patterns. And what they did was that pretty much they put an insect, a Polyestes wasp, in a maze. And it had pain, but if it ran to one of the faces, and these are a picture of fellow wasp, if it ran to the correct face each time, then it could avoid pain. Alright, so pretty much over time they wanted to see how efficient the wasp size was in recognizing each of their members' face and seeing which one was the right one to avoid pain, and if they could efficiently evolve facial recognition. Alright, so they did this with Polyantris metricus, which had a single founder's nest. And it was found that they had a very high efficiency of facial recognition. Alright, and this is perhaps attributed to why they only have one queen bee. Then they looked at the Polyantris fuscatus, who are flexible in their number of founderses. And they found that these ants, they were not as efficient as the single founder's nest ants, the metricus wasp. I didn't mean to say ants, I meant to say wasp. And they had a lower efficiency of facial recognition. And then you have, but they still found in the fuscatus ants, even though they were less efficient at recognizing faces, that they still recognize face patterns differently from other visual patterns. So my overall point of view about evolution of facial recognition in insects is that for these social insects, they're all able to recognize faces, but the efficiency varies between the type of insect and wasp. And the ones that are more efficient at facial recognitions are more efficiently able to define one queen. All right.